accuracy results in identifying and classifying skin cancer by removing noise from skin lesion. Detecting skin cancer at the earliest stage can help in reducing the risk factors in patients. Now we are going to see about the existing system of this project. In the existing system, the K-mean clustering technique using centroid selection is used to extract the cancer image accurately and efficiently. The K-mean clustering algorithm is utilized to extract the region of interest against which ground truth labels are specified. A comparative analysis has been drawn between the segmentation accuracy of the proposed improved K-mean technique and the standard K-mean. Both segmentation techniques have been utilized over the images within our data set, and segmentation accuracy have been recorded. Next, we are going to for the proposed system. In the research paper, we presented an intelligent system for classification of skin cancer into melanoma and nevus. It is observed that major problem that causes the misclassification is lesion detection and segmentation. The HSV, which is hue saturation value color transformation technique using centroid selection, is used to extract the ROI from the cancer image accurately and efficiently. The proposed techniques are GLCM, LPP, HSV, and SVM. HSV, which is also called hue saturation value. HSV in color imaging processing, there are various models, one of which is hue saturation value HSV model. Now we are going to see the advantages of the proposed system. Accuracy is increased and the average mean absolute error performance is also increased. This process runs fastly. It is easier to understand, and it is low cost and it is economic friendly. Now, next part will be carried out by S. Rojarani.
Now, let me explain about the block diagram. The first block diagram is input image, and the input image is used in fetching the captured image from the skin lesion, which is further going to be processed. And the second block is pre-processing. The second is pre-processing. It is the improvement of image data which suppress and enhance the image and into the required form of image. Here we use Gaussian filter to remove the noise. And the third block is segmentation. It is a very important step where we use the partition of the image into multiple parts using the hue saturation value, that is HSV, already explained by Pavitra. Comparing the hue values and the saturation parts, the value part is more suitable for further process. All this process can be further explained in the images. Now let's go to the next block, that is feature extraction. Feature extraction includes shape features, color features, geometrical features, and textures. As Pavitra already explained, gray level co-occurrence matrix, that is GLCM for shape features, and LBP, that is local binary pattern for color features. The classification is nothing but the machine learning process, which is based on the previous process. The image is classified, and it almost gives the final result. The final result, the images are processed and carried out, and the skin lesion in the images was classified as whether it is a melanoma or a lesion. Now let me explain the block diagram by each and every images. The input image. The input image is the one fetched which was captured from the skin lesion. And the second one is resized images. The image has been given to the MATLAB and then it is resized, comes under a pre-processing technique. Pre-processing technique is a common name for operation with lowest level of abstraction, both input or output or intended images. The another form of the pre-processing is implementing the image data that suppresses the unwanted noise data and enhances the details in the image. The contrast enhanced images. It is also comes under the pre-processing technique. It is the process of adjusting the digital image so that the result will more suitable for further image and analysis. For example, we can remove the noise, brighten up or enhance the images. Fourth is HSV images. HV images was just divided into 4 channels as we can see in the presentation. Here the melanoma, the right side is the nevus and the right side is a melanoma where they were categorized into 3 channels and the first channel was H channel, that is hue channel, then one saturation channel and third channel, that is value channel. As we can see clearly the V channel is considered for the process adjusting. That is because it is that's process through the channel. That is adjustment. Adjustment is very important where the image is more clear and contrast are more improved. The previous adjusted image is converted to black and white image in black and white images. Any color images is converted to black and white image because in this small portions, the very much clear of the lesion is observed. Here it is easy to classify as melanoma. Here the needed part is white color, which where the white and the left is melanoma and the right is nevus. In the complement image, the small particles are removed and the main objective of the image was considered to be a white color and unwanted particles are classified as in the black color. And the small objects are removed as I already said and the border correction is made to make the images more accurate and distinguish the lesions. And in the segmented images, the mixture of 2 colors like pink and peaches for the melanoma lesion is given and for the venous the gray with HSV method is also given. Next, the application of this classifications are to support the early detection, diagnosis and optimal treatment and for the image segmentation plays an essential role in many medical application. It reduces the testing process to achieve robust and accurate segmentation. Remaining part will be carried out by Kirtana.
Now let's see why software is used here. It is high-level programming language and it is very easy to understand. MATLAB has lots of time machine learning and deep learning toolboxes. The hardware used are Pentium dual core, 2 GHz processor.
Participants kindly stick on to the timings. 8 minutes for presentation, 2 minutes for queries. So kindly complete it soon.
Okay, ma'am. And 4 GB DDRAM and 15 color monitor and hard disk is 40 GB. Now future enhancement. In future research, the results can be slightly improved through many latest algorithms for removal of noise and with improved accuracy and efficiency. And these are the certain references that we have referred for this project. And these are the literature survey we have taken. And I thank everyone, my teachers, mainly our Prabhu Kumar sir, our HOD, the head of department, Mr. Prabhu, and our guide, Mr. Arun Rakesh sir. Thank you for giving us this opportunity to present.
Sir, Dr. Balsam, sir.
Students, very nice presentation. You are doing image
Thank you,
processing now.
sir. Thank you.
What is the size of the image to consider?
Sir.
How to step on the image?
Sir, we couldn't hear you, sir.
What is the size of the image you have to consider the input? You are doing MATLAB program now. Hello? Student?
Yes, sir.
What is the size of the image?
Sir, 1440.
What are the techniques used for classification?
For classification, we are using the technique. So for classification, we are using segmentation process, that is HSV, hue saturation values.
Okay, students, carry on.
Okay, one more question.
Thank you, sir.
Hello?
Yes, ma'am.
Pavitra, please. You told that is GLCM and LBP has been used for shape feature extraction, isn't it? Then for texture feature, which domain you will be using, which technique you will be using? Whether GLCM and LBP is used for shape analysis? Hello?
Yes, ma'am. Hello, ma'am.
Hello, are you using GLCM and LBP for shape analysis?
Yes, ma'am. We are using for shape analysis.
And then for texture analysis, what
For
techniques?
LBP, we are using color features.
Okay, for then texture analysis, what techniques you will be implementing?
HSV, ma'am. Hue saturation value, ma'am. SVM.
SVM you are using for texture analysis.
Yes, ma'am.
Okay, thank you.
Thank you, ma'am. Now we call upon the authors, Mr. R. Dayalan, Mr. P. Praveen Raj, Dr. A. Shivavalli, to present their paper titled IoT-based Health Monitoring System.
Please give me a minute.
Participants, kindly respond to the time. You have 8 minutes for presentation and 2 minutes for queries. Thank you.
Sure, thanks, ma'am. Am I audible?
Yes, you are audible.
So, good day, everyone. Before I begin my presentation, I would like to give you all a TED talk. We all have experienced a COVID pandemic in recent years. Yeah, yes, ma'am. Is my screen visible?
It's visible, you can carry on.
Okay, yeah, sure, thanks. We all have experienced the COVID pandemic in recent years, which is a traumatic time for human race. Many of our families and our neighbors died or suffered a major health problems. There was no room for patients in hospitals, and they died at hands because of shortage of health monitoring system. Many people died before they actually realized they have been affected by COVID. What stopped us? Even now, we may observe in many villages, there is only one hospital or clinics where the doctor used to visit the hospitals at irregular intervals of time. What happens to the patient's life when the doctor is away or out of town, or he may be not in his shifts? The patient may die or suffer a major health problems, right? So even in my home, my grandfather is half paralyzed as we failed to check his blood pressure level. This is a huge issue that we face still today. Why don't we figure out a method or how to solve it? So this is me, Dayalan, and yes, ma'am.
Your screen has not moved, sir. It is in the first slide itself.
Yeah, I haven't moved the screen.
Okay.
So this is me, Dayalan, and I'm working on a project IoT-based health monitoring system with my friend Praveen Raj P, and we are being guided by Dr. A. Shivavalli, ma'am. So let's get into it. No further delay. So as I mentioned earlier, on lack of health monitoring in India, 1.6 million people lost their lives due to improper health monitoring, says the WHO, World Health Organization. Why health monitoring system is very important? The answer is really simple. When we buy a mobile phone, we buy a temperature, a back case, and checks on the RAM and memory status and our security level, and we protect that our phone without getting infected by any virus. Actually, in the world, we humans are the greatest machine known so far. So it's our responsibility to check our health status too. And there are quite advantages of monitoring our health, which is it reduces the healthcare cost by reducing the physician office visit, hospitalization, and diagnostic test procedure, and etc. So from here, my friend Praveen Raj will be continuing. Praveen Raj, can you?
Okay then. Am I audible, ma'am?
Yes, you are audible.
Thank you.
Yes.
I'm continuing with the solution of our system. This is a very critical situation. To avoid this, we designed some embedded system to overcome this crisis. In this system, we continuously monitor the patient health by analyzing the two basic parameters like temperature and the pulse rate. Due to this continuous monitoring, if the parameters of temperature and the pulse rate crosses the threshold, we set up the threshold value as a normal normal body temperature and the normal BPM, beats per minute. If the parameters just cross the threshold value, means we just intimate to the respective caretaker or the doctor available in the hospital. Next slide. This is the block diagram of our system. In the center spot, we mainly focus on the two sensors, that is temperature and the pulse rate sensor. In the temperature sensor, we use the LM35 temperature sensor. It works like the basic principle of the diode. When the temperature increases, the voltage across the diode also increases. The temperature is analog only. That is, for the every 1 degree Celsius temperature change, there will be an output voltage of 10 millivolt. Therefore, we could analyze the temperature of the body. And next, we use the pulse sensor. Basically, in the pulse sensor, we have the two sides. That is, in one side, it has a LED and the ambient light sensor, and the another side, it has a circuitry for noise cancellation and the amplification purposes. Normally, once the heart pumps, the blood flow normally flows across the veins of the body. While the LED from the pulse sensor emits the light to the veins, means after the blood flow is noticed, the ambient sensor received some much of light reflected back from the blood. The reflected light monitors for a certain rate, and it decides the heartbeat rate. In the MCU, we used Arduino. The sensors are connected to the analog pins of the Arduino, and it transfers the data to the digital. And we here used two modules for displaying our parameters. That is, first we have to use the 16x to LCD display. In that display, we have displayed the temperature, that is the temperature of the patient's body as well as the beats per minute. And using the ESP8266 Wi-Fi module, that is, it operates in the 2.4 megahertz frequency range. From that, we have to transfer the data through the internet for the IoT platform. Next to the this is the circuit diagram. We already know that the Arduino runs in a 5-volt supply, and the pulse sensor and the temperature sensor are both the analog. Both are come across from the analog parameters. That is, the analog parameter transferred to the Arduino board, and that converted into digital data. And we use the ESP8266 Wi-Fi module as a two-way serial interface, that is UART communication. From that, we have transferred the data to the IoT platform. Next, results are carried out with
Thanks, Praveen. So in this, we observed the results from 10 persons in a hostel. So the A column will be the reading of our devices, which is this embedded devices, and B column is the reading which we took from temperature sensor, thermometer as well as pulse oximeter. So this is the embedded system that we used for getting the results, and we could see the results in the LCD display that is displayed. And through this Wi-Fi module, the results are transmitted in every 15-second frequencies to the IoT platform, which is ThinkSpeak, which has an API key in person to each and every candidate that they use it. And in that, the result will be stored for future reference too. So let me conclude our presentation by quoting Mahatma Gandhi's words: "It's our health that is real wealth, and it's not a piece of gold or silver papers." So thank you everyone for bearing our time. Any questions, ma'am?
Sir, Palchami sir. Ma'am, do you have any queries, ma'am?
Yes, ma'am. Yes, ma'am. How many patients you have monitored for your test?
10 patients, ma'am. Not patients.
Not patient. We just monitor the friends in my hostel, ma'am. In our hostel.
Only friend circle you have monitored.
We just compare the value. We just compare the value that our system.
That is, you have checked only with the normal patient, normal persons, isn't it? Not with the patient.
Yes, ma'am.
Then how can you claim for it as a health monitoring? If you are taking a patient, the temperature, pulse rate will be different. But if you are checking with your friends, that everything would be normal one, isn't it?
Yes, ma'am. We just check the accuracy of our system and the normal equipment in the market, ma'am.
Okay. When you are going to implement in the real time?
That we are working on it, ma'am. In future works, we could see that we are working on this product. And for future works, as of now, we are
Okay, okay, carry on. If your project is good, if you are really implementing in the health side, it would be very good. Okay.
Yeah, sure, ma'am. Actually, we are working on it.
Okay. Dr. Palchami sir is having some questions.
Sure.
Madam, am I audible?
Yes, sir. You are audible, sir.
Students?
Yes, sir.
What are the data collected for health monitoring systems? What is the basic input data in your systems?
So as of now, we have collected temperature reading as well as pulse reading, sir. And further, we are working to collect a breath sensor reading and heartbeat SpO2 sensor and oxygen cylinder level sensor also, sir. Hello, sir. Lakshmi ma'am, am I audible?
Hello?
Sir, you are audible, sir.
Ekada, madam?
Yes, sir.
Yes, sir.
Participants, try to answer the questions.
I think signal weak in my side only. Okay, ma'am.
No, sir. Your voice is clear, sir.
Okay. Sir, actually, as of now, we have used temperature sensor as well as pulse sensor, sir. And for future works, we are working on using breathing sensor, heartbeat as well as SpO2 sensor and oxygen cylinder level sensor, sir. Hello?
Ma'am, proceed, ma'am. I think some signal weak inside my side.
Okay, sir. Okay, sir. Thank you, sir. Thank you, students. You can carry on your projects.
Thank you.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am. Next, we call upon the authors, Sir S. Tangapandi, Mrs. T. Jayashree, and Mr. E. A. Muhammad Ali to present their paper titled Wearable Circular Patch Antenna with Aperture Integrated Ground for Frequency Applications.
Okay. Good afternoon, ma'am.
Kindly share your screen and start the presentation.
Yes, ma'am. Yes, ma'am.
Also, we request you to stick on the timings.
Okay, sir, ma'am, sir. Is it visible, ma'am? My screen is...
Yes, sir. Yes, sir. Visible, sir.
Respected chairpersons, faculty members, participants, good afternoon to all. Our research topic is wearable circular patch antenna with aperture integrated ground for data frequency application. Myself, Dr. E.A. Muhammad Ali, HOD, Department of Computer Science, JP College of Engineering, Tengasi. My team members are Mr. S. Tangapandi, Dr. T. Jayasinghe. So I would like to present my paper. I organized such that first one is objective and introduction, and the conventional or existing circular patch antenna that is considered here as iteration 1. Next one is the proposed work of our team, that is iteration 2. There is nothing but circular patch antenna with aperture introduced in the ground structure. So fourth, I would like to compare the performance of existing work, conventional work, in terms of return loss, voltage, standing wave ratio, gain, and operating frequency with the proposed work. So next, finally, I would like to conclude the research paper. So first one is objective of our research work. The objectives of the main objective of our research work or this paper are to design a novel wearable microstrip patch antenna for multiple operating frequencies. Then to reduce the size of the antenna, and finally to improve the performance such that return loss, voltage, standing wave ratio, and also improve the gain for all operating frequencies. Next, introduction part. So modern days, researchers pay more attention on the development of a single antenna that can be employed for multiple frequencies. Miniaturization of antenna is considered as an important factor. Fast growth in wireless communication field increases the demand for multi-band low-profile antennas. Compact devices are the prerequisite for the modern electronic devices and communication sector, especially. Hence, the necessity of small size, compact size, multi-band antenna is increased for wireless communication more than ever before. A conventional microstrip patch antenna exhibits very low gain and poor return loss performance. To improve the performance of the conventional microstrip patch antenna, various design techniques and geometrics such as slots, metamaterial rings, array structure are addressed in the literature. The slotted path and metamaterial ring designs are complex really in nature. Long size of the array antenna used for multiband operation is a major hurdle for its widespread applications. In this paper, defected ground structure is used for achieving multifunctionality with high performance. Effective ground structure is comprehended by integrating an aperture in the center of ground plane. The aperture integrated ground alters the current distribution and support for resonant frequency operation. Here, two iterations are carried out to achieve the tetra frequency antenna. Iteration 1 is the design of basic circular patch antenna. Iteration 2 is nothing but the proposed work, the design of aperture integrated ground antenna. So first part, I would like to explain about basic circular patch antenna. So the first iteration is a basic or conventional circular patch antenna with a full ground structure. Here, that is considered here. The basic circular patch antenna supports dominant DM11 mode. The resonant frequency of the conventional antenna is calculated by the formula FR equal to 1.8412 C divided by 2 pi A root of epsilon R, where C is nothing but the speed of light, A is the radius of circular patch antenna, epsilon R is the relative permittivity of the dielectric material. Here we use the substrate we are choosing cotton is a substrate for the material. The entire patch is laid on the copper substrate. The main features of copper substrate selected for this work is it is low cost, robust, and long life. It has long life. The geometry of the existing antenna, basic circular patch antenna, is shown in the figure. The badge here, the circular patch antenna, the badge is nothing but the circular patch with a radius of 10 millimeter. Okay, this is a full ground. The second structure is a full ground with the overall dimension of 2.8 cross 2.8 centimeters squares. So this feed line length, LF, and width of the feed lines are 7.1 millimeter and 3 millimeter. Here, the cotton is mainly used as a substrate material. The dielectric constant of cotton is 1.3. Let us understand the performance of the existing antenna by using first one is return loss. This figure shows the return loss characteristics of basic circular patch antenna. The main condition for return loss would be equal or less than -10 decibel. Okay, the antenna, we are well known about the design of antenna and the performance. Okay, the main condition that should be satisfied by the radiation pattern. This is a curve for S11. This is a S parameter curve. This is nothing but the return loss curve. Okay, the main condition, that is the return loss would be equal or less than -10 decibel. But here let us consider here the existing antenna operates in 18.1 gigahertz with a return loss of -7.44 decibel. Okay, in this first iteration. Okay, so this basic circular patch antenna fails to satisfy the minimum return loss condition. Okay, so let us improve the iteration 2. Here let us introduce the aperture in the ground. Okay, the second antenna is a proposed work. It's nothing but the iteration 2 is a circular patch antenna with the aperture defected ground structure, which is nothing but an aperture is introduced in the ground. Okay, so the work of the basic existing antenna, circular patch antenna, is optimized through this introduction of defective ground structure. Okay, here the resonant frequency is calculated by F equal to C divided by 2 LS root of epsilon aperture, where C is, we know, the speed of the light, LS is the length of the slot, epsilon is a dielectric constant of aperture material. Okay, where here we are also using the cotton material. So this is used for both wearable and other applications. Okay, here the geometry of the proposed work. Here the patch is nothing but a circular patch with a radius of 10 millimeter. Here the ground, we introduce a aperture in the ground. The aperture with a dimension of 4 cross 4 millimeter square. Okay, the aperture is located at the center of the ground plane. We introduce the aperture by using the wet etching process. Okay, so let us understand the proposed work. Okay, we have already discussed about the existing antenna. How the proposed work is excellent and performing well. Let us understand first of all the return loss. There is a S parameter curve. Okay, radiation is parameter curve here. This antenna is used for multi-frequency application. Here we have achieved this minimum condition for return loss that should be equal or less than 10 decibel. Here we achieved that in 4 different points. Okay, here in between, here let us understand this. At the resonant frequency 7.99, the return loss is -13.7. At next frequency level -12.7, here return loss is 17.6. Next one is at the frequency 16.4, that is -13.7, and the frequency 19 gigahertz, that is -14. Okay, so this antenna satisfies the return loss condition, and here we achieve the multi-frequency operation. Okay, at the 4 different band of frequency, we have achieved the return loss characteristics. Okay, so this antenna can be used for widespread application, wide range of frequency applications. Okay, let us understand it clearly. Next, let us move to the total gain of the proposed work. Okay, here we introduce the aperture in the ground. The proposed antenna generate additional current that disturbs the entire current distribution at the ground. Okay, that produce a hybrid mode of current distribution. So by changing the current path, that the operate is the analogy of this operation. Let us understand by LC circuit. Okay, that ensures the multi-radiation pattern. So total gain of the antenna is improved. The total gain is 2.29 decibel. Okay, here we can understand the total gain of the antenna by using this curve. By maximum gain is 2.29 is obtained. So let us understand the result and discussion of the proposed and also the existing work. Okay, so we know that these are the table 1 that represent the resonant frequency, return loss, and voltage standing wave ratio. The condition for voltage standing ratio is the voltage standing ratio should be very close, near to unity. That is the condition. Okay, voltage standing ratio is nothing but the matching, the impedance matching. Okay, between field line and the radiation pattern. Okay, so these are very important factor to understand the performance of the antenna. So the radiation pattern, the voltage standing VSWR should be very close to unity. Okay, here we have achieved the proposed antenna that perform well for different 4 frequency. Tetraband is nothing but the 4 different frequency band. At 7.9 gigahertz, the return loss is minus 13.73, and it is the VSWR very close to unity. That is 1.51. Next range in which the resonant frequency is 12.7 gigahertz, the return loss is minus 17.68. VSWR here is 1.3. Then third band of frequency of operation is where resonant frequency is 16.4 gigahertz, return loss is minus 13.7, where VSWR is also close to unity, 1.52. Okay, last band is at resonate at the center frequency 19 gigahertz with a return loss of minus 14.83 with a VSWR of 1.44. Okay, let us understand clearly here the size. The important objective of the antenna design is the size of the antenna. Okay, we have to reduce the size, miniaturize the size of the antenna. This is the main aim of our project. Okay, these are the recent literature survey here I tabulated here. A compact dual band multi-input multi-output antenna that is operating at the frequency 3.2 to 3.8 and also 5.7 to 6.2 frequency range with a size of 30 cross 28 millimeters square. Okay, and reported antenna, another one is recently reported antenna, a dual band slot antenna for wireless application that is operating frequency range 2.3 to 3.45 and 3.85 to 4.65 with a size of 40 cross 40 millimeters square. And next one is low profile strip loaded textile antenna. The range of operating range of frequency is 2.4 to 2.48 with the size of 60 cross 60 millimeters square. And next one is on body low profile textile antenna with the range of frequency is 4.3 to 5.9 with the size of 102 cross 68 millimeters square. Okay, let us understand here. Let us take our proposed work is a CPA with ADES. It's a circular patch antenna with aperture integrated ground structure that is operated very high frequency range. The range of frequency, let us compare the existing work with the proposed work. The range of frequency is also improved here, and also the antenna available is only operated in dual mode or tri mode. We have designed an antenna that is suitable for tetra band operation, 4 different range of frequency operation. Okay, that is from 7.65 to 8.01, radiated at the frequency 7.9, 12.33 to 13.2, center at frequency 12.7 gigahertz, 15.45 to 17.35, center at the frequency of 16.4 gigahertz, and the fourth range is 17.76 to 19.79 gigahertz, centered at 19 gigahertz, with a size of only 28 cross 28 millimeters square. Okay, we can here achieve the reduced size by using our proposed work. Okay, so let us understand this. I have already explained about VSWR. Okay, so here we have done a excellent work by in terms of VSWR. It is very close to unity for 4 different frequency ranges. Okay, next one is application. So for this antenna is designed for especially multiple bandwidth. Okay, here we have 4 different frequency, operating range of frequency. Okay, so we can use this antenna for various variety of widespread applications. Okay, for the range is 7.65 to 8.02, the proposed work antenna is also used for fixed and mobile satellite communication. And it is operated all under the range of 12.33 to 13.1. So it can be also used for broadcasting satellite communication. The range 15.45 to 17.35, it can be also used for radio location services. And 7.276 to 19.75, it's also used for Earth exploration stage satellite application. And the range 10.16 to 12.9 to the antenna also used for Earth exploration satellite communication, radio location services, broadcasting satellite and mobile communications. Okay, so let us conclude the overall presentation here. So this antenna is used for 4 different frequency of bandwidth. Okay, so it can be cover X, K, U, and K band of application. So this is very suitable for wearable application and also more other application like industrial, wearable, scientific, and medical devices, radio navigation application, and fixed satellite application. The performance-wise, let us be clear, it is realized, analyzed based on parameters like gain, return loss, VSWR, okay, operating frequency ranges. The result reveals that the proposed antenna with the defective ground structure ensures the wide multi-functionality with high performance. Okay, so thank you so much for giving this opportunity.
Thank you, sir. Dr. Palchami, sir.
Ma'am.
Yes, sir.
Sir, very nice presentation, sir.
Thank you, sir. Thank you so much, sir.
Wearable circular patch antenna with power.
Wearable. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
In your design a frequency in 4 type of frequency for antenna. Okay, sir.
Yes, sir. Yes, sir. The antenna is working in 4 different frequency, multi-frequency antenna. It is a reason, a novel idea. Already literature, there is a dual and tri-band frequency paper is available, but here the proposed work is suitable for 4 different frequencies, band of frequencies. So we can use this for multiple applications also.
Okay. So during the design of wearable circular antenna, sir.
Yes, sir. Yes, sir. Yes, sir.
The return loss is very important task now.
Yes,
Any
sir, yes.
difficulties to calculate the return loss, sir, for various frequencies?
No, sir, no difficulties. Here we are using HFS simulated software. We are also achieved that fabrication level, sir. But I didn't present here the fabrication of antenna. But we have done the fabrication and tested practically. Okay, the both fabricated and simulated results are very good, sir. Very almost equal. Okay, so
overall cost how much, sir?
Around 3,000 to 4,000, sir.
Okay. The size, sir?
28 cross 28 millimeters square, sir.
Okay.
Length 28 overall dimensions, sir. 2.8 centimeters, sir.
Okay.
Otherwise, 28 millimeters.
Sir, very good presentation. Nice topic. Okay, nice work, area. Okay, sir.
Okay, thank you. Thank you so much, sir. Thank you, sir.
Thank you, sir. Ma'am, do you have any?
Yes, sir. Yes, sir. Very good presentation, sir.
Thank you.
Sir, what about the radiation intensity, sir? You talked about return loss, everything. What about the radiation intensity?
I didn't take that parameter, the divination question, ma'am. But it is very minimum. But I didn't consider that parameter.
Okay, since you told it is wearable,
so
we have to mention that
another
one.
parameter that is called SAR, ma'am. That is how the radiation affect the human body. It's a wearable device. So the SAR is also minimum, but by 18% here.
Okay, so consider that also, sir. It is a
wearable. It is a wearable antenna. It's also used for medical application also. So the SAR should be also considered here. But I take only some 4 parameters. Thank you, ma'am, for your question.
Yes, sir.
That also considered here. SAR also considered.
Okay, sir. If you are mentioning that one, it will be giving a full justification for your title, sir.
Yes, sir. Yes, ma'am. Yes, ma'am. Yes, ma'am.
Thank you, sir. Thank you, sir. Wonderful presentation, sir.
Thanks. Thank you so much, ma'am. Very kind of you.
Thank you, sir. Thank you, ma'am. Next, we call upon the authors, Mrs. S. Jeeva and Dr. S. Anand, to present the paper titled Qualitative Improvement in Wireless Capsule Endoscopy Images using single scale Retinx function with unsharp filtering.
Yes, ma'am. Good afternoon, ma'am. Whether my voice is audible?
Yes, ma'am, you are audible.
1 minute, ma'am. I will share the screen. The PPT is visible?
No, ma'am, it is not visible, ma'am.
1 minute, ma'am. Whether my screen is visible, ma'am?
No, ma'am, it is not visible, ma'am. Shall we share from our side, ma'am?
1
It
minute.
is not visible, ma'am.
Ma'am, kindly share your from your side, ma'am. Ma'am?
Yes, ma'am.
Ma'am, kindly share your from your side, ma'am.
Yes, ma'am, yes, ma'am.
Thank you, ma'am. Good afternoon to all. Myself is Jiva, Assistant Professor of ECE Department at Ramco Institute of Technology. My research work is qualitative improvement in wireless capsule endoscopy images using single-scale Retinx function with unsharp filtering under the guidance of Dr. S. Anand at Professor ECE Department at MEPCO Engineering College. And this presentation includes abstract objective of this proposed method, introduction, motivation of this research work, and some few literature survey, existing work, and proposed method and diagram. Final resultant discussion, performance evaluation and comparison. Finally, ended up with the conclusion and reference. And the image enhancement is very essential tool for in the image processing application because the wireless capsule endoscopy is a non-invasive method. It is used to track the GI tract and also find out the various problems like small bowel disease such as polyps and Crohn's diseases. So in this paper, we use the existing techniques histogram equalization, adaptive histogram equalization, and propose the one new novel method that is single scale Retinx with unsharp masking. Here, histogram equalization is used to be a simple and effective image contrast enhancement method. But here we use the global histogram equalization with the help of single scale Retinx algorithm with unsharp masking technique. The main objective of this proposed method is to improve the quality of the wireless capsule endoscopy images. This enhanced image is very helpful for highlight the details and improves the overall contrast of the images, which is helpful for medical diagnosis purpose. That is the main objective of this proposed method. So here the virus capsule, this GA tract images is captured by using the virus capsule endoscopy. The normal wired endoscopy is very pain for patient as well as the discomfort for size. So better we go for the virus capsule endoscopy. This will be introduced on 2000 itself. Nowadays we use the pill cam for wireless capsule endoscopy. Take the images by using the pill cam camera. Sir, next slide, sir. So this pill cam has the 8 parts importantly. First one, optical dome. It is the receiving, that is the light receiving window. And the second one is the lens holder. It is behind of the receiving window. Then lens, it is the integral component of capsule. It is used to receiving the images in the GA tract. And here we use the 4 types of LEDs. Then CMOS image sensor is used for to highlight the images and enlarge the quality images. Then and also it take the images at the degree of 140-degree view, and it can detect the images as much as small as possible. And battery, here we use the silver oxide primary battery. It is a disposable and does not cause for body. And ASIC transmitter, it is the 2 transmitting electrodes are connected for the receiving endo. It is captured the image from the optical dome. And then finally ended up with the antenna. It is the end of the capsule. It is enclosed in a dome shaped enhanced. And this type of image enhancement, these types of images are used to identify and diagnose the various diseases in the GA tract, particularly for Crohn's diseases, GI bleeding, celiac disease, tumor, ulcer detection, polyp detection. These are the main disease diagnosis by using these pill cam images. So based on this study, the main motivation of this proposed work is because the virus capsule endoscopy images are found dark and poor quality. The image is very white, and when camera is near for the images, so the images are compressed before sending the data. It will be very useful to enhance the data, is very important for the diagnosis purpose. So it is the main motivation to enhance the quality of the virus capsule endoscopy images in a medical image processing enhancement techniques. So another literature survey, various global and local enhancement methods are available. For 2016 is the tensor based diffusion method. The mainly finding of this one is the contrast enhancement. Forward that next one is use the forward and backward anisotropic diffusion method. The another method of the image enhancement is color and position based, because the virus capsule endoscopy is the color image. We have convert this color to RGB. Otherwise, we have to convert this luminance HSV images. We perform that images in the both modes, RGB and HSV modes. Then next, a multi-scale blood model detection is used to find out the bleeding patterns of the WC images. So this is the one another technique. Next. Another methodology is edge profile based appendical orifice image detection algorithms. It is used to find the appendix classification. Another method is SVM classification. It is used to classify the ulcer images and normal WC images. The another one is edge detector and log Gay-Bar filters method. It is used to find the polyp detection and ulcer detection. So all the techniques are used for the parameters accuracy, sensitivity, otherwise error parameters like MSC, PSNR or structural similarity values. The next methodology is supervised statistical classification method. It is used to assessment of Crohn's disease and lesions. Another method is color feature extraction using first order histogram of RGB plane. Here we use the single order histogram equalization. It is used to find the bleeding detection. Next methodology is by using the transform domain methods. At that time, he used the discrete cosine transform. It is the image enhancement. The parameters are PSNR and the sharpness enhancement values. Next methodology is luminance, chrominance, and quadrature component color scheme. It is used to find the ulcer detection. Another paper 2016 proposed proposed methodology is image histogram. It is also used to find the ulcer detection. So various methodologies like unsharp masking, local binary pattern, and contrast limited adaptive histogram equalization, that are the all the local histogram enhancement techniques are available. So all the methods are used to find the ulcer and lesion detection. So recently, some transformation methods are available. Adaptive fraction gamma transformation with color component restoration and feature acceleration. Supervised and unsupervised learning methods are used for the next methodology. That also used to enhance the WC images and bleeding direction. Application purpose we used to find the bleeding. Then nowadays these pre-processing techniques are implemented in used for the machine learning applications. The fusion of deep convolution neural network and geometric features. It is used to find the GI disease detection and classification. It detects the various diseases like polyp detection, ulcer detection, Crohn's disease. So depends upon the accuracy. This CNN model pre-processing techniques will be varied. Then finally, AA and ML techniques are available, so that will be also used for bleeding and detect multiple abnormalities. So these are the literature surveys. So based on this literature surveys, in this proposed method is compared with the two types of existing methods. The one is histogram equalization and another one is the adaptive histogram equalization. For histogram equalization is the this method is to distribute the gray levels within an image. So it is very every gray level is enhanced in equal manner. So it will increase the brightness and contrast of dark and low contrast images. Then adaptive histogram equalization is differ from the normal histogram because it respect to the particular adaptive points to enhance that particular points in the gray levels. So it is suitable for improving the local contrast of an image and bringing the more picture details. So our proposed method is the combination of the single scale Retinex with unsharp masking. So first we have to collect the data set of GA tracked images. That images is undergone the single scale Retinex cell function. The single scale Retinex function is basically a logarithmic function. It is used to enhance the contrast of the image as well as the reduce the noise content also. So in this so for this one we use the single scale Retinex function is a first step. Then after that single scale Retinex function is given to the unsharp masking. The unsharp masking is a unsharp masking technique is used with various nonlinear filters like Wiener filters and logarithmic function filters. So here unsharp masking is used to enhance the detailed features. So we use this unsharp masking followed by the single scale Retinex. So after that we get the enhanced image. Then we have compare the performance of this proposed method with the existing method like histogram equalization and adaptive histogram equalization method. So here I am used the Cavasier data set. This data set consists of 4,000 images. So 4,000 it contains the 8 sections. The 8 sections has various diseases images like dyed lifted polyps, dyed resection margins, esophagitis, normal cesium, normal pylorus, and normal Z line, polyps, and ulcerative colitis sections. So each section has the 500 images. So in this proposed method, I am using the polyps, one of the image from the polyp detection, and I am using the software as the MATLAB release 2021A for this project work. And single scale Retinx, it is the function of the logarithmic that will be use the original image of the ith band section. So each level we apply the logarithmic function, logarithmic linear function. It is used to enhance the contrast of the original image, as well as the reduce the noise content, and also used for the reduce compression technique. Then unsharp masking. So unsharp masking method is to increase the sharpness of the image contrast. So it is the most known method for contrast image enhancement. It is usually implemented by using the Laplacian operator. And our proposed method is combination of SSR and USM, single scale Retinx function with unsharp filtering or unsharp masking function. Here SSIR only is not capable for providing the sufficient details. So the output of the SSR is sharpened by using the unsharp filtering. So the proposed method is provide the better enhancement image compared to the ordinary spatial domain enhancement like histogram equalization, existing method histogram equalization and adaptive histogram equalization, and also the performance parameters are also calculated and compared with the previous existing methods. So this is the result of the technique. So here 4 images are depicted. The figure A depicts the original image. So the original image is getting from the Cavasier data set. That RGB image is converted to the gray level. So the first figure A depicts the original image, and figure B depicts the histogram equalization. So here histogram equalization is enhance the all the gray levels in equal manner. So the figure B depicts mostly moreover white images like evenly enhanced. Then figure C depicts the adaptive histogram equalization output, which improves the luminance and contrast, but it is generate the artifacts in the bright area. So it is the one disadvantage. So compared to the histogram equalization, adaptive histogram gives the better detail, but it also enhance or contrasts the brighter region as a noisy manner. So it is the one disadvantage of the adaptive histogram equalization. So the figure D depicts the proposed method single scale Retinx with unsharp masking. This provides the this enhance the illumination content with qualified details and preserves the information in detail. So compared to the histogram equalization and adaptive histogram equalization, the proposed method SSR USM provides the better illumination contrast and provide the detail information as well as. So this is the result part of this proposed method. Then after that quality improvement, we also find out the quantity parameters. Here we use the various enhancement parameters are available. In this proposed method, I am using the 3 parameters for mean square error, peak signal to noise ratio, and single structural similarity index. So mean square error is low, means it provides a better contrast. Then second parameter is peak signal to noise ratio is calculated between the original image and the contrast image. This PSNR is higher, means it provides the better contrast. Then third parameter is structural similarity. Most of the enhancement techniques like image enhancement as well as medical image enhancement technique, we use the SSIM is the main important parameter of the enhancement. It is the structural similarity. The structural similarity is calculated between the contrast, that means output image and the input. When the SSIM is higher, that means nearer to 1, means it provides the higher similarity index. That is the main advantage of the SSIM parameter. So compare, I am taking the polyp deduction. So we find out the histogram equalization, MSC, PSNR and SSIM for existing techniques, histogram equalization, adaptive histogram equalization, and the proposed method SSR is ESM. For the MSE value compared to the existing methods, our proposed method has the lowest MSE, so it gives the better contrast. Similar for PSNR parameter, and our proposed method gives the more values compared to the previous, that means existing method. And also the third parameter SSIM, our proposed method is 0.7005, it is nearer to 1 compared to the histogram and AHE. So for both qualitative and quantitative, the proposed method SSR USM is provide the better contrast and structural similarity values. And this is the comparison chart for MSE PF, and the first figure, A figure, depicts the comparison chart for mean square error and PSNR. So here the our proposed method is the lowest MSE and the highest PSNR value, and figure B depicts the SSIM value for the existing method and proposed method. The proposed method provides the nearer to 1 value for SSIM. So as the conclusion, the proposed SSR USM method conquers all the drawbacks and gives the better contrast enhancement. And proposed method provided the useful geometric features, but also have effective control noise compared to the AHE and the Clake method, and also it provides the better image quality, less error, and noise control with the high structural similarity. So these are the references. Thank you, sir.
Thank you, ma'am. Very nice presentation.
Thank you.
Sir, Pancham sir, do you have any questions, sir?
Student,
Sir?
your topic is qualitative improvement of wireless capsule endoscopy images now.
Yes, sir.
Okay, it can be applicable for real-time images, ma'am.
So now I am applied to the data set only, sir. But future work we plan to collect the real-time images, and also this pre-processing technique is work out for the CNN model, sir. That work is going on, sir.
You can use any special filter, ma'am.
Now we are using the filter. Specific filter is not used, sir. Unsharp masking only used.
Okay. What is the evaluation parameter finally?
Evaluation parameter, here I am using the MSE, PSNR and structural similarity, sir. Okay. So noise control purpose, I am using MSE and PSNR, and the contrast enhancement, the similarity can be represented by using SSIM, sir. Okay.
Are you compared with any existing methods?
Existing methods, the local enhancement method like histogram equalization and adaptive histogram equalization, sir.
Okay. Are you compared with the result?
Yes, sir.
Okay. Okay. Thank you, carry on.
Thank you, sir.
Thank you, sir. Ma'am, do you have any queries, ma'am?
No, ma'am. No, ma'am. Thank you.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Next, we call upon the authors, Ms. S. Harini Sriram, Dr. K. Raghavan, Ms. S. K. Bhavitram Sri, to present the paper titled Fruits Recognition Classifier Implementation Using Convolutional Neural Networks.
Ma'am, is it visible now?
Yes, visible.
Thank you. Bhavi? Bhavitra? Are you there?
Bhavitra, kindly start your presentation.
Okay, good afternoon, Mundra present here. The project titled Fruit Resonation Classifier Implementation Using Convolutional Neural Network. And then this is our introduction. We know that fruit classification is a major task in nowadays. If we develop the fruit classification system, it would be implemented in supermarkets and wherever possible. And our objective is to classify the fruit images using the convolutional neural network. And then this is our proposed method. In this work, we have pre-processed the input message using local contrast enhancement. Then this message is fed into CNN, that is convolutional neural network for classification. The CNN consists of 3 convolution layer, 2 max pooling layer, and 3 batch normalization layer, and 3 relu and 1 fully connected layer, and 1 classification layer. These are some of the literature survey we have record. This is our proposed method. This is the input image. We have taken the input image from Fruit 360 data set. And then the input images of size 100 cross 100. Then this input image is fed into pre-processing stage. Here, the local contrast enhancement is performed. After that pre-processing, that image is fed into CNN for classification purpose. That is this Fruit 360 dataset consists of totally 131 classes of images, but we have chosen only 6 classes of fruit images. This is an image capsule. The input image is taken from Fruit 360 dataset. It is an RGB image. I have placed one of the image here. And this image is pre-processed, like local contrast enhancement is performed for bringing out the detail and texture in an image. Then this is our convolutional neural network. We know that this convolutional neural network consists of input layer and output layer. In between, we have multiple hidden layers. This is our own CNN architecture. Input image is fed into this input layer, which is of size 100 cross 100, then followed by convolution, batch, relu. Here we have chosen the convolution layer window size is 3 cross 3 and number of filters is 8. And then max pooling layer is of filter size 2 cross 2. This is our results and discussion. This Fruit 360 dataset consists of 131 classes of fruit images. In that, we have chosen only 6 classes of fruits. They may be apple, red one, avocado, banana, dates, grape blue, and then mango. This total number of images used for training is 178. That is, we have chosen the image from this dataset. One is of 0 degree and another image is of somewhat tilted. That is 45 degree one image tilted, and then 90 degree 180 degree. That is data augmentation is performed here. And then the total number of images used for testing is 1591. These are the some of the sample images from Fruit 360 dataset. This is your variation of classification accuracy with respect to the learning rate. Here I have chosen, I have trained the CNN with 1782 images. And then I have tested with 1591 images. I have chosen the epoch is 10. Then I have varied the learning rate from this 0.001 to 0.1. For this, I have achieved the better accuracy for this learning rate 0.01. Then I have chosen this for the upcoming projects. And this is a variation of classification accuracy with respect to epoch. Here I have set the learning rate as 0.01. Then I have varied the epoch. For this, I have obtained the classification accuracy for most of the cases. From that, I have chosen the epoch as 10 for further processing. Here, this is the variation of classification accuracy with respect to window size. Here, I have varied the window size from 3 cross 3 to 9 cross 9. For that, for all the window sizes, I got the accuracy as 100 only. These are the sum of the training progress plot. Here the epoch is 10 and learning rate is 0.1. For this, I have obtained the classification accuracy as 100. These are some of the images we have obtained from This is our conclusion. This is what presents the fruit classification technique using your CNN. We have trained the CNN with 1782 images and tested with 1591 images. From this observation, we have set the learning rate as 0.01 and epoch 10. Window size is 3x3. For this, we have obtained the classification accuracy is 100. We didn't compare our results with the existing results because we have taken only 6 classes of fruits. So that we didn't compare our results with the existing methods. These are our application. We have implemented this food classification system in supermarket, agriculture, industry, exports, and then etc. These are future enhancement. This work can be extended to classify more fruits, vegetables, seeds, and nuts, etc. This can be implemented in real bad scenario. And then a mobile app can be developed that will be given to a farmer and then retail normal human being, whatever. These are some of the references. Thank you. Thank you.
Student, very nice presentation. You are using convolutional neural network now?
Yes, sir.
It is applicable for any other neural network?
Yes. Yes, sir.
Yes, sir.
How many images can you collected for test images?
Sir, 131 classes of fruits, sir. But in that project, we have chosen 6 classes of fruits, sir.
How many sample images?
1781 sample images we have taken, sir.
Yes, sir.
Initial purpose, huh?
For initial stage, we have chosen this, sir. We have enhancing this work, sir. This is a part of the work, sir.
Why you select especially for convolutional neural network?
Sir, the output is clear, sir. Better than SVM, other than sir. Yes, sir.
So nowadays the trend is going on towards a convolution neural network, so that we have chosen this, sir.
Okay. Thank you, students.
Thank you, sir.
Hello, ma'am. Hello.
Yes, ma'am.
Okay. What are the features you had taken for classification of fruits? What are the features you would be taken for training the data sets?
Ma'am, sorry, ma'am.
Features. What are the features you have concentrated for training the classifier?
Ma'am, we have given the image to CNN only, ma'am. Like a shape, color, and then enhancement. Shape and color we have concentrated, ma'am.
Shape and color around you have concentrated. Okay. For example, if you had given only with the color features, only 2 features means if same color of fruits, if you are given means how it is possible to classify it properly, whether you tested that one?
Oh, yes, ma'am. Yes, ma'am. But we have not tested that. We will concentrate on that area, ma'am.
Okay, ma'am. Thank you, ma'am.
Okay, thank you, ma'am.
Any queries from participant side? In the chat box, some queries are available. Is there any literature review?
Yeah, we have referred some literature review, sir. We have listed in the PPT itself. Aruna Kumar, sir.
Okay, ma'am. Thank you, ma'am.
Thank you, sir.
Thank you, sir. Thank you, ma'am. Next, we call upon the authors, Mrs. G. Subhashini, Dr. R. Rajalakshmi, Mr. S. Jagatishwaran, and Mr. Salvadurai to present the paper titled Development of Gyro Stabilized Electrobot.
Am I audible to everyone?
Yes, sir, you are audible.
Yeah, thanks. Hi, everyone. Wait a minute. Hi everyone. I'm Jagdishwaran from ECE College of Engineering and Technology. I'm very delighted to be here today to tell you about our gyro stabilized electrobot. My talk is divided into 9 main sections, which is objective, overview, literature review, hardware and software description, and etc. etc. Okay, first get into the topic. The first and the main topic is objective, to demonstrate the techniques involved in balancing an unstable robotic platform on two wheels, and to design the complete discrete digital control system that will provide the needed stability, and just slightly move on to the next topic, which is overview, right? Design and control of a two-wheel self-balancing robot to develop the balancing an unstable robotic platform automatically by using the motors, sensors, and the microprocessors. The use of a pair of motors. It is to keep the robot in an upright position by using an accelerometer and gyroscope sensors. This will provide a classic inverted pendulum problem. Yeah, generally the accelerometer sensor is much noisy, but they are accurate over a short time of period. By using the sets of the results obtained from the sensors and the calculated results, it can be solved the problem. Solve the problem like a classic inverted pendulum. And therefore the robots can be kept in the upright position without falling down. Next move on to the next topic, which is a literature review. The single loop and double loop balancing bicycle, which was published in the IEEE conference on the robotics and biometrics. This is the IEEE paper describes about the improvement in the performance of AUSB. The methodology of this paper is followed in the proposed method, but it also having the particular disadvantages like a single loop control system. It does not perform as expected. And the next design of self-balancing bicycle, and the next review is the design of self-balancing bicycle using object state detection, which was published on an international conference on international automation computing 2014. This paper describes about the balancing a two-wheeler bicycle without the support of any extra wheels. Here, this is the first paper which introduced the PID controller logic to this system. But this project is having the disadvantages, which is the counter rotating wheels are not performed as expected. And the next paper is stable balancing motion analysis of a bicycle robot with front wheel drive based on the moment balancer, which was published in the IEEE 2010 International Conference on Intelligent Computation Technology and Automation. They used a DH technology. DH methodology, and they just simulated this whole project by using the MATLAB simulation. The main drawback was they doesn't concentrate on the prototype. They decided to improve the performance by using the whole drive. And the next review is steering control based self-balancing robot of a bicycle robot, and they use the Lagrange method for a dynamic modeling, but they can't achieve the upright position. This paper was published in IEEE International Conference on Robotics and Automation. And next move on to the next topic, which is a literature review survey. In methodology, the authors have initially defined the system parameters. Respectively, they have developed the mathematical models. Most of the dynamics are based on the Newton-Euler equation, Lagrange-Euler equations. The sensors like a gyroscope, accelerometer were used to acquire the system positions and responses. Based on the sensor response, the required output was fed into the controller. Right, the LQ or PID, etc. The control methods were used to the control system. And next, move on to the next topic. This topic is already familiar to all, but the question is what we did specially. We used the LQR controller because it performs better than the PID, which was previously used. They used the Kalman filter. It used to obtain the efficiency than the complementary filter. First, initially we go for the complementary filter. After that, we have attained the maximum level of response from the Kalman filter, and lost the And the last point, our robot is made to drive on the 45-degree slopey surface. It is a high maximum than the previous one, which is a 30-degree slopey angle. Okay, let's move on to the next topic, which is a hardware architecture. An illustration of the hardware is used to work is described in the diagram. The two DC motors are rigidly attached to the microcontroller at level 328. Gyroscope and accelerometers are mounted on that unit between the wheels connected to the DC motors. The motors have encoders built in that enables the reading of the position of the robot. Next we are going to see about the software description. The software architecture is divided into digital control system, human-machine interface, and the initialization module. A sampling module reads the sensory information at 250 Hz. The sampled data is used by state estimator that produces the state estimate at the same rate. The digital control system is responsible for keeping the robot in an upright position. The angle and the angular velocity is sampled at 250 Hz. A Kalman filter estimated the system states which are used by an LQR controller to achieve the state feedback. A HMI and that HMI displays relevant data and responds to the user inputs. Let's move to the next topic, which is a circuit diagram. Now we can see the simplified, currently updated circuit diagram. I just concentrated on the Arduino's active part to the motors through the motor drivers. Here is the Arduino act like a CPU controller. This is the final result of my wait a minute. The result and analysis overall, the result of the project is satisfied as shown in the diagram as well the video. The performance of the PID controller and the control algorithm exceed our initial expectations. Further over the algorithm exceed improvements. Would require a better hardware platform to test and tune the parameters on. A direct drive system with the price control could be an ideal drive mechanism. This will have a more accurate for absolute positioning. This move would allow more tweaking and tuning of the algorithm. Let's move on to the conclusion. The project was aimed to fabricate and test the working of the self-balancing robot. The design and fabrication of the robot are correct with the fixed position. Its components are designed at the maximum amplitude of vibration. The robot body can tolerate the sudden force to the good extent. In the case of failing the horizontally on the ground, when it goes out to the limited balancing zone. The maximum zone is minus 25 degree to 38 degree tilted angle in which the robot can balance itself without any external help is analyzed properly. Okay, let's move on to the future work. It can be enhanced to work with the vehicle's mechanics. It can be added as a safety feature in two wheels. Then the advantages are the Segway robots used in such way as travel forward as word. They can be used by vehicles by human. They currently in the current day the short distance usage vehicles can be submitted by them. These vehicles can balance themselves sideways whenever the rider loses his balance. The road accidents. It can decrease the road accidents, right? It can use it in the rocket propeller. Works on the it can based on the inverted pendulum problem, so it can also use it for the rocket propeller. This is the gyroscopically electronic vehicle. It can avoid the accidents rate. The robotic arms and also it having a more advantages like a robotic arms can attached with this pick and place robot for the purpose of warehouses, hotels, and malls and etc. It can use it to develop the self-balancing wheelchair for the disabled persons. That's all. Thank you. Thank you for this opportunity too.
Students,
Yes.
how much total cost of the project?
It's just nearly 5,000 to 6,000 rupees.
That is very low cost.
Yeah, yes. We just used Arduino and gyroscope and cheap rated drivers. That's only we can estimate it as 5,000 to 6,000 rupees. It weighs only 900 grams.
Okay, any special platform for software?
No, we used the Arduino based software only.
Software.
But in future, we discussed about the cloud based Python in the by the replaces of Arduino softwares. In the hardware side, we discussed about a Raspberry Pi.
Okay, can you extend the application especially for this purpose? Other than this, you can told no the differentially able to people like that.
Yeah, yes, and also in the view of the military purpose, military camping purpose, hill station can be able to climb in a 45-degree of slopey surface.
Okay. Thank you, students.
Okay, thank you.
Thank you, sir. Ma'am, do you have any queries, ma'am?
No, ma'am.
Okay, ma'am.
I'm honored to serve.
Yeah, thank you, ma'am. Thank you.
So it's time for the vote of thanks.
Kalchami sir, can you give a brief about our session, sir?
Okay, ma'am.
Yes, sir.
First of all, I convey my sincere thanks to Ramco Educational Institution, give the opportunity to act as a chairperson of the International Conference on Smart Technologies and Application 2022 in the special domain of image processing. And convey my special thanks to Dr. Lakshmi Ma'am, Associate Professor, Department of Electronics and Communication Engineering, Ramco Institute of Technology. Give the very care and support to act this person for especially this domain of image processing. Based upon my observation, that today's session started on 11:45 to near about 2 o'clock. I have so totally 8 papers. The paper ID 56, a review on brain tumor analysis and classification using deep learning, is a very nice paper relevant to medical image processing. This paper clearly focuses on the analysis of brain tumor, how to classify used upon the real-time domain of deep learning methodologies. The second paper ID 134, AI-based mobile cyber mechanism for tillage development. It is a special robot design, especially for agriculture. In this current scenario, the agriculture is a very important domain for all the agriculturists. So the design of agriculture robot is very important one. This paper is very nice one. The third paper, paper ID 136, the classification of melanoma and nervous in digital images using machine learning techniques. It is a classification techniques for image processing. The fourth paper, paper ID 145, IoT-based health monitoring system. It is the remote villages areas. The health monitoring system is a specific domain of the Internet of Things. The paper ID 201, the qualitative wearable oscillator patch antenna with aperture indicator ground out terafrequency applications. The professor clearly focus on how to design the 4 type of frequency based upon the design, especially for wearable circular antennas, and the return loss calculation is very nice. This presentation is very good. Then paper 303, the paper serial number 6, the qualitative improvement in wireless capsule endoscopy images using single skull retinox function with the unsharpened filter. It is also the based upon the real-time images of endoscopy images classification and enhancement process. The paper ID is 316, the serial number 7, the fruit classification. The classifier is especially used in the convolution neural network. The convolution neural network based classification is very important for the classification of retinal images. The last paper is very nice one. The development of gyro stabilized electro robot